Black Knight Unmanned Combat Vehicle. Are we on the brink of a new era of warfare, where unmanned vehicles reign supreme on the battlefield? The Black Knight Unmanned Combat Vehicle seems to suggest so. With its impressive capabilities, it's no wonder that the U.S. Army is putting it through extensive testing. But what exactly makes this vehicle stand out from the rest? Design. The Black Knight, an innovative unmanned ground combat vehicle, UGCV, has been developed by BAE Systems to provide an exceptional military asset. This state-of-the-art prototype weighs approximately 12 tons and is designed to be deployed from a C-130, a military transport aircraft. The Black Knight is similar in appearance to a tank, with its turret-mounted 25mm gun and a 7.62mm coaxial machine gun adding to its combat prowess. The vehicle boasts a powerful 300 horsepower, 220 kilowatt Caterpillar Inc. diesel engine, allowing it to maneuver effectively in challenging terrains. The Black Knight's cutting-edge technology and advanced capabilities make it an invaluable asset to the military, and it is currently undergoing evaluation by the U.S. Army to assess its full potential. The Black Knight's maneuverability is also enhanced by its suspension system, which consists of a torsion bar and hydropneumatic suspension. The torsion bar helps absorb shock and provide stability, while the hydropneumatic suspension allows for the vehicle's height to be adjusted for different terrain types. The suspension system also helps to reduce the noise level of the vehicle, making it harder to detect by the enemy. Additionally, the Black Knight is designed to be air transportable, which means it can be easily deployed to different locations around the world for missions. Functions. The Black Knight's ability to provide ground intelligence and fire support makes it a valuable asset on the battlefield. The vehicle's sensors allow it to observe the enemy from a closer range than a manned crew could safely approach, providing critical information to other armor and dismounted personnel in the area. The Black Knight's autonomous and semi-autonomous features allow it to assist manned crews in various tasks, enhancing their overall effectiveness in combat operations. Development. The Armed Robotic Demonstrator (ARD) project began in 2005 and 2006, with the aim of assessing the performance of earlier unmanned vehicles. The ARD made its public debut in 2006 at the Association of the United States Army in Washington, D.C., generating considerable interest among military experts and enthusiasts. In response to the attention the ARD received, a remote operation capability was added to the vehicle in 2007. The Black Knight, as it is now known, was then showcased in the annual Air Assault Expeditionary Force (AAEF) field trials at Fort Benning, Georgia. After passing stringent safety conditions, the tank underwent testing in the fall of 2007, operating successfully for over 200 hours. Despite the promising performance of the Black Knight, the project was ultimately discontinued. However, in March 2017, BAE Systems reintroduced the vehicle as the Armed Robotic Combat Vehicle, signaling a renewed commitment to developing advanced unarmed combat vehicles. Specifications. The 2007 presentation by BAE demonstrated the Black Knight tank's potential as a reconnaissance vehicle. The unmanned tank was able to move into a position of cover, observe battle damage, and transmit valuable information to a manned Bradley fighting vehicle crew who were engaging in a simulated target with kinetic fire. The Black Knight's ability to report back on the target's condition without requiring additional crews to move into a potentially vulnerable position is a significant advantage. It is capable of navigating any type of terrain, including rocky terrain and water bodies. This capability makes it an ideal choice for military operations in challenging environments where traditional manned vehicles may not be suited. In military testing, the Black Knight has proven to be an invaluable asset, allowing soldiers to determine the vehicle's capabilities and how best to integrate it into more advanced military forces. Its autonomous and semi-autonomous features have revolutionized the way operators plan and execute attacks, allowing for a more strategic and efficient approach. The vehicle's advanced technology allows it to avoid obstacles while navigating from point A to point B, making it a valuable asset in any military operation. The Black Knight is made up of 3 distinct modules: the robotics operator, the mission commander, and the safety officer. Each of these modules serves a specific purpose, allowing for efficient and effective communication between the vehicle and its operators. The robotics operator is responsible for the vehicle's day-to-day operations, while the mission commander is responsible for overseeing the mission as a whole. The safety officer is responsible for ensuring that the vehicle operates safely and in compliance with all relevant regulations. Control system. The Black Knight is designed to be operated through the Robotics Operator Control Station, ROCS. The ROCS is located inside an armed vehicle, allowing the operator to remotely control and direct the vehicle's autonomous operations. The robotics operator is responsible for controlling the vehicle's movements, as well as operating its weapons and other systems. The mission commander plays a crucial role in the Black Knight's operation, tasked with interpreting and analyzing the data received from the vehicle's sensors and systems. This data is then transmitted to the ROCS, allowing the robotics operator to make informed decisions and take appropriate actions. The safety officer is responsible for ensuring the safe operation of the vehicle, particularly in emergency situations. In the event of an unsafe situation, the safety officer can use a remote hand control to issue an emergency stop command to the Black Knight, bringing it to a halt and preventing potential harm to personnel and equipment. Additionally, the safety officer is responsible for ensuring that the vehicle is properly parked in a designated location after completing a task, such as a garage or onto a truck. Significance. UGCVs, such as the Black Knight, offer several advantages to military operations. Firstly, they can operate at any time of day, even in missions that are deemed too dangerous for manned ground vehicles. This includes forward scouting, reconnaissance, surveillance, target acquisition, RSTA, intelligence gathering, and investigating hazardous areas. One of the most significant advantages of the UGCVs is their ability to investigate areas that are too hazardous for a group of soldiers to enter. This not only reduces the risk of injury or death to soldiers, but it also allows operators to receive critical data from unmanned forward positions. This requires significant coordination and interoperability efforts to ensure smooth and effective operations. Moreover, there are ethical considerations surrounding the use of unmanned systems in combat, including questions of accountability, responsibility, and decision-making. These issues need to be carefully addressed in order to ensure that UGCVs are used in a responsible and ethical manner. Finally, there are concerns over the potential for UGCVs to be hacked or otherwise compromised by malicious actors, which would lead to disastrous consequences. Ensuring the cybersecurity and resilience of these systems is therefore of utmost importance. Comparisons. It's interesting to compare the Black Knight with the Chinese ZSD-63 autonomous UGV. Both vehicles are unmanned ground combat vehicles, but they have some key differences. One major difference is that the Black Knight was specifically designed as an unmanned vehicle, while the ZSD-63 was originally designed as a manned vehicle and then retrofitted with autonomous capabilities. This means that the Black Knight systems were built from the ground up with unmanned operation in mind, which could give it an advantage in terms of performance and reliability. Another difference is in the sensor capabilities. While both vehicles are equipped with advanced sensors, the ZSD-63 sensor array includes LiDAR, radar, and video stations mounted on the front of the vehicle. This gives it a more comprehensive view of the battle space, compared to the Black Knight sensor suite, which is mounted on top of the vehicle. It's also worth noting that the ZSD-63 is an older vehicle, dating back to the 1960s, while the Black Knight is a newer design. However, the ZSD-63 has been retrofitted with modern autonomous capabilities, which could help to level the playing field somewhat. It seems that both the Black Knight and the ZSD-63 autonomous UGV have advanced sensor arrays, with the Black Knight using LiDAR, thermal imaging cameras, high-sensitivity video cameras, and GPS. The Black Knight also has advanced autonomous mobility capabilities, allowing it to navigate and plan routes without pilot intervention, detect and avoid obstacles, and operate day and night. However, It's difficult to make a direct comparison between the two vehicles without more detailed information on the capabilities of the ZSD-63 autonomous UGV. As countries like China develop their armored vehicles, it remains to be seen how the Black Knight will stack up against its competition. Nonetheless, its advancements mark an exciting step forward in military technology. With that said, thank you for watching. Don't forget to like and subscribe to our channel. Also, press the bell icon so you never miss an update. See you in the next video.